Let's talk about this sort of niche formula in AP Calc that has to do with the derivative of an inverse function. But in order to sort of understand and appreciate where it comes from, let's first talk about a few properties of inverse functions. You'll notice in the graph, I've drawn the function f and the function g, which are inverses. And one of the properties that you'll notice right away is that when two functions are inverses of one another, they are a reflection of one another about the line y equals x. And one of the corresponding properties of that is that if the point A comma B is on the graph of F, then the point B comma A is on the graph of G. That'll come into play in just a minute. Also, you probably learned in a previous course, like Algebra 2 or Pre-Calculus, that if F and G are inverse functions, then algebraically, if you form their composition, you're going to get X. This is true both of F of G of X and G of F of X. Either composition results in an output of X. And that's where we're going to start to connect this to calculus. I'm going to take the derivative of that function, of that equation, I should say, with respect to X. The derivative of f of g of x is f prime of g of x times g prime of x. That's a chain rule application. And the derivative of x with respect to x is 1. And now I'm going to solve for the term g prime of x by doing division. Now that's close to, but not exactly how the formula generally appears in a calculus context. Usually it looks more something like this, that g prime of b is equal to the reciprocal of f prime of g of b. I'm going to show you a couple of applications of this in calculus problems. So here's the first. We are told that f of x is this cubic function, and very importantly, they make the connection for us that g and f are inverses of one another, and we're given a point on the function f, which is the point 0, comma 1. The question asks us to find g prime of 1, so we're going to take advantage of this formula in order to do so. I want to first remind you that if the point 0, comma 1 is on f, then the corresponding point on g is 1, comma 0. And that's going to be very important as we apply this formula. The formula tells us that g prime of 1 is going to be the reciprocal of f prime of g of 1. And because of this relationship between f and g, where the x and y coordinates are switched, we know that this becomes 1 over the derivative of f at 0. In order to finish the problem therefore, we're going to need to find the derivative of the function f, which we can do using the power and chain rules. F prime of x is equal to 3 times the quantity 2x plus 1 squared, there's the power rule, times 2, there's the chain rule. 6, 2x plus 1 quantity squared. And furthermore, f prime of 0 is 6 times 1 squared, which is equal to 6. We're going to slide that right into our formula to get our final answer. And that is that g prime of 1 is equal to 1/6. In this case, letter D. Now we'll talk about this formula in a slightly different and more complex application, and that is in response to this free response question. They start off in the stem by telling us now that g inverse is the inverse of g. That's a fairly common notation. And they asked us to write the equation for the tangent line. And as you know, to write the equation of a tangent line, you need two things. You need a point, which may or may not be the y-intercept, and you need the slope. Now specifically, our goal is to write this equation when x is equal to 2. So in order to find my point, it's important to consider that I'm looking at the function g inverse, and I want to know the y-coordinate when x is equal to 2. And keep in mind that if that's true of the function g inverse, then the corresponding point on g is going to be something, comma 2. Again, because those coordinates are swapped. Going over to my table, I can note that g of x is equal to 2 when x is equal to 1. So 1 is the x coordinate on g, corresponding to an output of 2, and that means that 1 is the output value on g inverse, corresponding to an x coordinate of 2. All right, so there's my point, 2, comma 1. Let's talk about the slope. We're going to get the slope by using the formula. G inverse, prime of 2 is going to be the reciprocal of g prime of g inverse of 2, which is the reciprocal of g prime of 1, and we can read that value from our table. G prime of 1 is 5, so the derivative of g inverse at 2 is going to be 1/5. And that allows us to complete the problem. The equation of the tangent line will therefore be y minus 1 is equal to 1/5 times x minus 2.